The P0089 fuel pressure regulator performance. The schematics and procedures used in this video are typical of most vehicles. Always refer to the manufacturer's specifications before commencing any work. The high fuel pressure necessary for direct injection is supplied by the high pressure fuel pump. Most high pressure fuel pumps are driven by the camshaft and are mounted at the front or rear of the cylinder head. This high pressure fuel pump also regulates the fuel pressure using an actuator in the form of an internal solenoid controlled valve. In order to keep the engine running efficiently under all operating conditions, the Engine Control Module, or ECM, requests pressure ranging from between 290 and 2,176 psi, or 2 and 15 megapascals, depending on engine speed and load. Output drivers in the ECM provide the high pressure fuel pump actuator control circuit with a 12 volt pulse width modulated, or PWM, control, which regulates fuel volume by closing and opening the control valve at specific times during pump strokes. When the control solenoid is not powered, the high pressure fuel pump operates at maximum flow rate. In the event of a high pressure fuel pump control failure, the high pressure system is protected by a relief valve in the high pressure fuel pump. This valve prevents the pressure from exceeding 2,538 psi or 17.5 megapascals. The fuel rail pressure sensor provides the feedback necessary to the ECM to control the high pressure fuel pump and the fuel injectors. The fuel rail pressure sensor is diagnosed separately from the fuel pressure control system and will be covered in another video. During engine crank and running conditions, the ECM monitors the fuel rail pressure sensor to determine if the commanded and actual pressures are within specifications. The ECM will only run the diagnostic for P0089 once predetermined conditions have been met. For this vehicle, the engine is running. The ignition voltage must be over 11 volts. The low side fuel pressure is greater than 40 psi or 275 kilopascals. The barometric pressure, or baro, is greater than 10.2 psi or 70 kilopascals. The intake air temperature, or IAT, is greater than 14 degrees Fahrenheit or minus 10 degrees Celsius. This readiness or monitoring cycle runs continuously when the above conditions have been met for a minimum of 10 seconds. DTC P0089 will illuminate the malfunction indicator lamp, or MIL, if the diagnostic runs and fails. All operating conditions at the time of the failure are recorded to freeze frame data. Let's start our diagnosis by looking at fuel system pressure. Incorrect low pressure can affect the high pressure circuit. Connect a fuel pressure gauge to the low side fuel supply. Start the engine and allow to idle. Confirm that the low pressure is to specifications. If not, diagnose the fault in the low pressure system before continuing. If the low pressure is within specification, you will need to check the high pressure. Verify the fuel rail pressure sensor parameter is within specifications for the vehicle. It is not recommended to use a mechanical fuel pressure gauge in the high pressure side of the fuel system. Always follow manufacturer's instructions when completing these tests. Using a scan tool, check that the fuel rail pressure sensor parameter is within specifications. It may be necessary to monitor the fuel system data while road testing the vehicle. Confirm that the desired pressure and actual pressure readings correspond with changes in engine speed and load. Follow the freeze frame data if available. If the fuel rail pressure does not respond to ECM commands, then some physical tests must be performed. Inspect the feed pipe from the high pressure pump to the fuel rail for any leaks or restrictions. Test for any fuel contamination which may cause the fuel pressure regulator or injectors to stick. High resistance within the regulator solenoid or a faulty rail pressure sensor may also trigger this DTC. To check electrically, we can carry out a resistance check within the fuel pressure regulator solenoid. Switch the ignition off. Unplug the harness connector at the high pressure fuel pump. Check for corrosion and correct terminal tension. Using a digital multimeter, perform a resistance test across the pressure regulator solenoid terminals and compare to specifications. If the resistance is not within range, it will be necessary to replace the high pressure fuel regulator assembly. If the reading is okay, check for short to ground within the fuel pressure regulator solenoid. Using the meter, check for infinite resistance between each terminal and the regulator housing. If any reading other than infinite is displayed on the meter, then there is a short to ground within the solenoid and the fuel pressure regulator must be replaced. If the resistance readings are within specifications, then the high pressure fuel pump must be removed and the drive inspected for damage or excessive wear. Before opening the high pressure fuel system, it must be depressurised. Always follow the manufacturer's procedure when doing this. Once the cause has been found and repaired, clear the DTC and perform the pressure regulating valve and fuel trim reset with a scan tool if applicable. When road testing, be sure to complete the appropriate drive cycle for this DTC. Drive the vehicle through different throttle and load ranges. Perform a wide open throttle as well as a deceleration test. You will need to repeat the test several times to ensure the fuel pump actuator operates throughout its entire range. Stop the vehicle and perform a full ignition cycle. Confirm the DTC has not returned. This DTC may be caused by mechanical faults within the high pressure fuel system, electrical faults in the high pressure fuel regulator, the rail pressure sensor, or any problem within the low pressure delivery system. Understanding the system before commencing work ensures a correct, professional and cost-effective repair. And remember, diagnose, don't guess. Thanks for watching, bye for now.